Yeah, so your standard form is that ax squared plus what? Bx, what else? Plus c, good. So that's your standard form for your quadratic equation, yeah? Your graph, when you graph it, it makes a U-shaped curve. What's the fancy word for that? It's a parabola, spelled like parabola. Parabola. Then for the next two, they're giving us equations, and it wants us to use our graphing calculator to sketch it. So I don't even know that we really need that, y'all. What is this graph going to look like? What's positive? It opens up because what's positive? Your A value is positive. We know it's going to open up. So the only thing that we don't exactly know is about our zeros, right? Because you know you can have 2, 1, or none. I remember what that looks like. So like where you cross twice, you could have 2. You touch it, you have 1, or it never touches at all, and you have like 0. So we don't know what's going on with that. So grab your calculator if you don't already have it. Type that in real quick so we can get a better idea of what the sketch is going to look like. So there's my graph. Is that what y'all's look like? How many zeros do we have? 2. Again, your zeros are where you cross the x-axis, right? So we've got 2 of those. So you just need to make sure that you cross twice and open up. Is that okay? And that's going to be our sketch. That's all we're going to do. Questions on that? Okay. So same idea for the next one. This time we've got negative x squared plus 3x plus 7. So what's going to be different? It's going to open down. So we know that's going to happen. Let's graph it to see about our zeros because we can't quite tell just from looking at that what's going to go on with those. So that's what mine looks like. Is that what you got? Okay. Yeah. So we're going to open down, and it's got 2 zeros. So you just need to make sure you cross twice and open down. And that'll be it. Okay? So if your A is what? Then the parabola is going to open which way and look like a smile. If it looks like a smile, which way is it opening? It's opening up, and your A is positive, exactly. So then for the other way, if A is what? Negative, which way are you going to open? The parabola opens down. And it's going to look like a frown. Good, good, good. I want to add one thing while we're here. Do y'all remember what we discovered on Friday? With those C values? It's your y-intercept, right? So if you look at our graph, does that look like it crosses at like -5? And your y-intercept, yeah. What about this one? Does it look like it crosses at +7? Yeah. So remember that. So your C value is your y-intercept. Do you want to write that somewhere? That'd be good, right? Let's jot it down over here. C value is your y-intercept. So the next section is talking about your axis of symmetry. What is the little bitty formula that we use for axis of symmetry? Negative what? Negative b over 2a. Good. And that gives you your x value of your vertex. And remember, it's like that imaginary line that we could fold it over and it would be the same on each side, or you can use that to help you reflect points when you're graphing. your vertex is like your turning point. Yeah, I think that's what we've been saying for it. When it's the lowest point on a graph, what have we called it? Your minimum. What if it's the highest point? It would be a max. Good. Right, so we've got one example we're going to look at the bottom, and then we'll move on to some other things. So we've got x squared plus 8x plus 15. It wants us to find our axis of symmetry. So what's the formula that we're using? Negative b over 2a. What is our b value? So we've got negative 8 over 2 times a. What is our a? 1. What is 2 times 1? So then negative 8 divided by 2, what do we get? Negative 4. So how do you write your axis of symmetry? Good. X equals negative 4. Remember, it's the equation of a line, so you've got to have that x equals part, not just the negative 4. Then we need to find our vertex. How do you do that? Plug in negative 4. So we're plugging into our original function they gave us. So we're going to have negative 4 squared plus 8 times negative 4 plus 15. What is negative 4 squared? 16. And what's 8 times negative 4? Negative 32. And plus 15. So 16 minus 32 plus 15, what do you get? Is that okay? How do we write our vertex? Ordered pair. What's the x value? And what's your y value? So we want to sketch this. So we'll have our little graph. Your vertex or your turning point happens where? Oh, this is not good. Okay. Negative 4, negative 1. I did not do a very good job with this. So we're going to go pretend negative 4 and negative 1 is about here. Is it going to open up or down? Going to open up. How do you know? That x squared is positive. And one more thing that we can tell. Your y-intercept, where's it going to happen? Positive 15. Remember, that's your c value. So that's going to happen somewhere way up here. I didn't quite draw in for that. But we know that your parabola is going to open up like that. Yeah? Is that okay? I didn't do a good job of drawing a good area for that. But that's okay. It's a little scratched. Questions? Are we okay with all those steps that we just did here? Yeah? Okay. So you picked up this page on the way in. So we're going to graph, and we're going to use those steps that we just did to help us get there, okay? So we'll do a couple of these together, and I'll let you finish the rest on your own. So you've got the steps at the top of your page for how it wants you to do this. You're going to start by finding your axis of symmetry. Then you'll find your vertex. Then we'll be able to build a table of values, and then we can graph it based on our points that we got from our table, okay? So very first thing, find your axis of symmetry. What's the formula that we're using? I'm going to write that up here beside of axis of symmetry. I'm going to say x equals negative b over 2a so that we've got it the whole time. So what is our b value right now? 0. So if we put 0 over anything, what's it going to be? So your axis of symmetry is 0. So I'm going to say x equals 0. We need to find our vertex. How are you going to do that? Plug back in. So when you plug in 0, what is 0 squared? 0. So your vertex is where? 0, 0. So at this point, I'm going to hop over to our table. And we know that the vertex is like the middle, right? So I'm going to put that in the middle of our table. And we want to know what's happening on either side of it, right? So what would be two numbers bigger than 0? I would use 1 and 2. What are two numbers smaller than 0? Okay. So let's plug those in. so we can finish our table. Now this is a really easy function, so we can just do this in our head. When you get to some of the others, it's going to be a little bit more complicated, so you can use your calculator to help you with that. So if we're plugging in -2, what is -2 squared? 4. Then you're plugging in -1, which gives you 1. What about when we plug in +1? 1 again. And when you plug in +2? 4 again. Good. So let's plot those points. We're going to have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Are we good with the graph? Yeah? Okay. So the last things that it's asking us for are your domain and range. So domain is talking about what? X's. And since we're talking about this graph, we're looking at our X's on our graph. Is that side to side or up and down? Side to side. So how far to the left do we ever go? Do we know? Why does it keep going up? How do you know it keeps going up? It's the arrows, right? Because it keeps going for forever. So can we chop it off on one end and say it never gets smaller than -5? Can we do that? Does that happen? No. So we don't know the smallest it gets. What about the largest that it gets on the other side? Can we chop it off and say it'll never go past this? No. So what do you think we put for our domain? A phrase. So it could be like everything, right? What's a phrase that we use for like all possibilities? There you go. That's going to be true every single time, y'all. So your domain for every quadratic ever is always going to be all reals. So really, right now, what could you go fill in for every single one of these problems? For what? For your domain. All reals. Go put it everywhere. So y'all should at least get that right on all of these. Now your range is going to be a little bit different, so we're going to talk about that next. What does range want you to look at? Your y value. So on a graph, that's not side to side anymore, but what? Up and down. So we got to find the lowest that we ever go. What is it here? 0. So we know our lowest is 0. And what's the biggest that we ever go? We don't know, right? So we just know that your y's are always bigger than 0. So we could say, put a y and then say greater than equal to, because the, other way. The y is bigger than that. Does that make sense? At all? Maybe a little bit. Questions there? So we're good with finding the range? That makes sense? Because it's all your y's bigger than 0? Okay. So let's do another one together. Can we do number 3? Yeah. Alright. So going through this whole thing, what was the first thing that we found? Axis of symmetry. So what's our formula that we're using? Negative v over 2a. So what is our b value? So we've got negative 8 here. Now on the bottom we have 2 times a. And what is a? Negative 1. So negative 8. What is that? Positive 8. 2 times negative 1 gives you what? Negative 2. So what's 8 divided by negative 2? Negative 4. So your axis of symmetry is what? Good. X equals negative 4. Then you need your vertex. How do you find that? Plug it back into your original. So we've got negative negative 4 squared minus 8 times negative 4 minus 17. Do y'all want to just type this in the calculator? There's a lot going on there, so we can do that. I'm going to type it exactly as we have it written here. So are parentheses important? Yes, absolutely. So parentheses, negative 4 squared minus 8, negative 4. What'd you get out? I got negative 1. Is that what y'all got? Yeah? Okay. So how do we write our vertex? Negative 4, negative 1. So we've got 1 point that's going to be on this graph. And you know that your vertex, or your axis of symmetry, is in the middle, right? So I'm going to go to our table, and in the middle, I'm going to write negative 4, negative 1. Because we want to know what's going to happen on either side of that, right? So negative 2, negative 1, 0, 1, and 2, like we did for the first one, doesn't always give us exactly what we need to see. So if you put your vertex in the middle, you're going to get good points around it, and you'll have everything you need to go ahead and get a good sketch. Does that make any sense? Okay, so we're always going to go put your vertex in the middle. I'm going to draw an arrow right here to help us remember that's what we did there. What are two numbers that are going to be bigger than negative 4? Negative 3, negative 2. If we go the other direction, go smaller. Negative 5, negative 6. So then we've got to find values for this table. So there are like 3 options for us here. We could plug them all in by hand and see what you get. You could plug in each number in your calculator one at a time and see what you get. Or we could put it in the graph and put the table there and then just copy from the table. What do y'all want to do? Copy from the table? I think that's going to be the easiest thing. So we'll go to a new graph and we're going to type in our function. So we've got negative x squared minus 8x minus 17, and we'll hit enter. So we know that this is what our graph is going to look like eventually. But we've got to get the points before we can get there. So how do you do that? How do you get points? Control T pulls up our table, and then we're just pulling values for the numbers that we already have. So we need to scroll up so that we can see all those. So we've got negative 6 through negative 2. What do we need to get from negative 6? Or what do you get out from negative 6? Negative 5. What do you get out from negative 5? Negative 2. What do we get out from negative 3? And from negative 2? Negative 5. Is that okay? We're just pulling those straight from the table. I think that's the easiest way to do it. Is that okay with y'all? Yeah. Is it the only way to do it? No. So you can do it other ways too. If you don't like that, you don't have to do it that way. I just think that's easier, and I'm all about saving time. So let's graph this real quick. So we've got negative 6, negative 5, negative 5, negative 2, negative 4, negative 1, 3, negative 2, 2, negative 11. So we already said before that every single time your domain for quadratics is going to be what? All real numbers. Is going to go forever in both directions, side to side. But your range is going to be a little bit different. So this time we're opening down. So it's going to go down to infinity for forever, right? So we know that all your y values are going to be smaller than something. What's the highest up that our graph ever goes? Negative 1. So we'll say that all of our y's are going to be less than or equal to negative 1. Is that all right? So the range part is a little bit tricky, and we haven't done a whole lot with it yet, but I want y'all to go ahead and try doing all those. Do we need to do another one together, going through all the steps? Anybody need that? So we're okay to do the rest on our own?
Yes.
Yes?